All right, students, we just talked about how to evaluate algebraic expressions, and today we're going to look at simplifying algebraic expressions. We have a bit of vocabulary that we need to talk about, so we're going to go through a few of these terms, and then we're going to look at some examples. And the first term we're going to look at is terms. The terms of an algebraic expression are the parts separated by addition and subtraction. Let's look at an example so we can make sure we understand this. Let's look at 3x squared plus 2a plus 4 minus 7a. In this case, we have 4 different terms because there's 4 parts that are separated between the additions and subtractions. There are 4 terms, and I want to list those terms. The first one is 3x squared. That comes before the first addition sign, so 3x squared. The next term is going to be 2a. The one after that is 4. We call it a constant term because it just has a constant. There's no variables. And then the last term we have to be careful. It's not 7a. It's going to be negative 7a. When a term is being subtracted or is otherwise negative, that negative is a part of the term. So the terms here are 3x squared, 2a, 4, and negative 7a. And there's 2 terms here that are special. You've probably noticed 2a and negative 7a are special because they both have a as their variable, and we call these like terms. 2 terms are called like terms if they have the same variable factors. And when we have like terms, the thing that we can do is we can combine them. So let's rewrite this: 3x squared plus 2a plus 4 minus 7a. I like to underline like terms, just kind of as notation to show myself that that's what I'm combining. So the 3x squared is going to stay there. Then we can combine the 2a and the negative 7a, and we do this by combining the coefficients, the numbers out front. Here we've got 2 minus 7, that gives us negative 5, so that's going to be negative 5a. And then we also have this positive 4 term that needs to be brought down. So our simplified version is 3x squared minus 5a plus 4. We want to combine like terms whenever we can because that gives us a simpler expression, one that has fewer terms. And if we want to do something else with it later, like evaluate it, there's going to be less work when there are fewer terms. Let's look at a couple more examples of combining like terms. Let's take a look at 5x minus 4x squared plus 2x plus 5x squared. Do we have any like terms here? Well, we actually have 2 pairs of like terms. 5x and 2x are like terms because they both have x as the variable factor, and negative 4x squared and 5x squared are also like terms because they have x squared as the variable factor. So we can combine each of these pairs individually. 5x plus 2x gives us 7x. Remember, we add or combine the coefficients, but we leave the variable parts the same. And then if we have negative 4x squared and 5x squared, those are different signs, so we take the difference. 5 minus 4 is 1. 5 is larger, so we're going to have positive 1x squared. So we've got 7x plus 1x squared. And when the coefficient, the number out front, is 1, we generally tend to not write it. So we would just write that as 7x plus x squared. The reason these are the same is because anything times 1 is itself. So here we have 7x plus x squared as our simplified version. I've been using the term coefficient, and I haven't defined it, so let's actually write that out now. The coefficient of a term is the numerical factor. the number out front that things are getting multiplied by. Let's do 2 more of these, and then we'll be done with combining like terms, and we can move on to the distributive property. Let's take a look at 3ab plus 7 plus 4a plus 2 plus 5ba. All right, are there any like terms here? Well, most students see that 7 and 2 are like terms. They're both constants. They can be added. And usually the class is 50-50 split between whether 3ab and 5ba are like terms. Half of the students usually say they are, and half usually say they aren't. And everyone is certain that they're correct. But of course that can't be true. We can't have them being like terms and not like terms at the same time. I'm just going to tell you the answer. They are like terms. And the reason is because AB represents A times B. This is a multiplication. And when we're multiplying 2 quantities, we know the order doesn't matter. So A times B is the same as B times A. So these are like terms, and we can combine them. 3ab plus 5ba gives us 8, either AB or BA. I will default to putting things in alphabetical order. I think that makes sense. And then 7 plus 2 gives us 9. We can combine those as well. And then we have to bring down that 4a. It doesn't combine with anything, but it is still a term in the expression, so we need to keep it there. And this gives us 8ab plus 9 plus 4a. Now, if you had done this in a different order, maybe you put the constants first, 9 plus 8ab plus 4a, or you had done it in some other order, it's still correct. The order of terms doesn't matter because terms are added, and we know that when we add things, the order doesn't matter. So there we are. We've got one more that I want to look at before we move on. T minus 4x minus 7t minus 9t. All right, here we're looking for like terms. And here we have 3 terms that are like terms. T, negative 7t, and negative 9t all have t as the variable factor. Now, these last 2, you can see the coefficients negative 7 and negative 9. In the first one, it's not written, but the coefficient there is 1 because t is the same as 1t. So you can write it in if that helps. Now, when we combine these, we have to take the coefficients and combine them. So we've got to take 1 minus 7 minus 9. 1 minus 7 gives us negative 6. And then negative 6 minus 9 gives us negative 15. So we've got negative 15t. And then we bring down that minus 4x. And so we've got negative 15t minus 4x. All right, that's it for combining like terms. In the next video, we're going to also look at the distributive property, and we're going to see how we can use like terms and the distributive property to make certain algebraic expressions much simpler.